this was pretty simple and obvious because, the space is a new territory. And the mastering of new territories is impossible to imagine without transport. The invention of and proliferation of new means of moving, like people and goods, like railways, aviation, containers, this has created the modern economy that we know. Space exploration is not an exception. But the physical nature of this territory creates enormous challenges. Because here on Earth, we are on the bottom of this huge gravity well. To deliver cargo into orbit and defeat the gravity, you need to accelerate things to the huge velocity, 8 kilometers per second. It's 20 times faster than a bullet. So, and as a result...
20 times faster than a bullet. Holy cow. That's a great metaphor to help people understand. Please continue.
And finally, less than 5% of the initial rocket starting mass reached the orbit. So the answer actually lies how to make it cheap. It's lies in reusability and in mass production. But the tyranny of this rocket science, we basically contribute to the large rocket sizes unnecessary. And it drives the strategy for companies like SpaceX and Blue Origin, who developing huge, big, gigantic reusable rockets, like, SpaceX developing like Starship or New Glenn. And we will see this launch cost into space that will be just a few $100 per kilogram and will open a lot of opportunities. But then the problem is the rocket's only efficient to launch masses into low orbit. But if you need to distribute cargo to different orbits or deliver to the top of the gravity well, like a geosynchronous orbit or to the moon or different elliptical orbits, you need to add additional 3-6 kilometers per second, so another 20 speeds of bullet. And if you use conventional rockets for this, the proportion of the mass reduced from 5% to 1%. So to deliver 1 ton of a cargo, you need to start with 100 tons. In many cases, if delivered mass is much less than capability of future low-cost rockets, you need to use more expensive small and medium-sized rockets. And it all requires multimodal transportation, connecting flights, which actually never was used in space, when you have huge, cheap rockets delivering cargo to low orbit. And then last-mile space vehicles, space taxis, distributing cargo between orbits to the higher orbits. And this is why we created Momentous in 2017, because we developed these space tags and hub-and-spoke multimodal transportation to space. And we are having our first full commercial mission actually early next year in January with the Falcon 9 rideshare. But the main challenge, how to build these space tags and the technology very cheap and very low cost. And the answer is how to build actually the nature of the propellant that they're using actually contribute to the cost a lot. If you use a chemical propulsion with this cryogenic liquid oxygen, it's expensive. If you use this high pressure xenon, which is extremely expensive, it's also expensive. So we come with the idea to use water as a propellant. And it's not only make our vehicles extremely cheap. I like to tell that our vehicles look like from Mad Max movie. So actually it's simple. It's damn simple. There are no moving parts. But also the water is most common mineral in the solar system. You have water everywhere. In the moon craters, you have water in asteroids. So it means we're building technology that not only have these short-term advantages, but long-term, because we have this gift given by us to us by the solar system process of evolution, the water. And we build this long-term sustainable way how humanity can move to this new element, to the solar system, to the space.
And what is how does that affect the average person? If I ask you, what's the future of space? What is Momentous really trying to do? And how will that benefit the average person so they get a perspective as well? Why do you want to create this? And what's it going to do for the average person here on Earth?
The people actually do not sometimes underestimate the value of even existing space technologies. Let's imagine that tomorrow will happen some solar flare and all satellites will be disappeared. Actually, it can happen, by the way. It's there are some probabilities that in case of the big solar flare, all satellites will be wiped out. What will be in this case? It's not only you will lose probably your a TV connectivity, you will lose a signal of the precise time, so all the cache machines stop working. You will lose a GPS signal, so there are no navigation, there are no paper maps and then people cannot use, Uber Eats, DoorDash. It will be hunger all over, like because people cannot now like get the food. I mean, we so much living with this, but actually it's not enough even now, like a space sensors. For example, it was a huge forest fires in California, and I was a CEO of one of the largest forest company in the world, and I knew that if you can detect the forest fire within 1 hour after it started, you can actually easily to fix it with just helicopter or with drones. But now there are no satellite constellation that can detect it within 1 hour. It can take maybe once a day. Or for even agriculture, I mean, to collect data about soil moisture content, there are no a satellite constellation that collect this data. I'm not talking even about internet. We're living here in the Bay Area, and we don't have cellular coverage in some places, so there are no internet. So hopefully, with a Starlink and other projects, it actually create a new category of services. Space economy is pretty small now. So just $400 billion. It's 0.1% of global GDP. But what we believe that we are on the verge of this new big gold rush in space. And it will be many applications and many new users that can drive this economy to become $1 trillion and change all our life.
Wow. And again, I want people to know this is not something that you're dreaming about. You got contracts at NASA. I saw your stock just dropped almost 30%. Is that right? Was that the number I saw? People are starting to jump on and say, wow, he's got a technology that can make us have space travel be so much cheaper. And also all these resources, moving satellites around, there's so much space junk people don't realize that's out around the Earth now that's starting to fall into the atmosphere. It's starting to become a real issue, but no one's even thought about space trash before. But you have the ability to propel and move things in a different position or capture them. So it's pretty darn exciting what you're doing.
Yeah.
So if I asked you the future of space, what does that look like coming through your eyes as a pioneer working with these other pioneers?
I think the final future of space, that it will become more self-sustainable. So people will use the space and space applications to do many things, for manufacturing, for energy production, for data mining, for asteroid mining, for getting all this rare and precious metals from the moon or from other asteroids. And it sounds like a fiction, but actually we see that the number of satellites that launched, 10 years ago, it was launched 70 satellites. This year, up to now, it was launched more than 1,100 satellites.
1,100 satellites this year alone. That's wild.
Just this year alone. And 10 years ago, it was launched just 70 satellites a year. And this just now, it's 1,100 satellites alone this year.
How many satellites are around the Earth right now, circulating around? Do you know?
Around 10